Okay, section 9.8, Compound Inequalities. Okay, let's just jump right into this and let's start talking about how a set is a collection of objects or numbers. This is going to become way more apparent here shortly. I'll kind of have like a little Venn diagram to show you. Okay, and we got to think about items in a set, they're elements. Okay, so you can almost think of a set as like a grocery shopping bag or a grocery cart. Okay, that is your set. Okay, everything you put in it is an element. Okay, so sets are indicated with braces. Okay, and they're named with capital letters. If elements are listed within the braces, it's said to be in roster form. So let's see, kind of give an example of what that looks like. Say I have a set here, set A, and we're going to call it set A, and it's going to contain 3/4, 1.7, 3, 8, and root 2. Okay, I could also have a set that contains all the whole numbers. Whole numbers start at 0 and they go 1, 2, 3, 4, ... all the way, and they never stop. Okay, I could also have a set that contains all the integers. All integers go to negative, so you could have a -4, and also ... sorry. -3, -2, -1, 0, 1, 2, ... n, all the way up to infinity. This is what it's saying. Okay, this right here is your set. These are your elements inside the set. And then here's the braces. Okay, so this right here is called roster form. Let's look at something else. Let's see this little symbol, this little weird E. That just stands for is an element of. So looking at the sets I made, you can see that 1.7 is a set A, is an element of. I apologize. So 1.7 is right here. Notice it's an element of A. Okay, 0 is an element of the whole numbers. -3 is an element of the set integers. Okay. Let's scroll down. All right, union, intersection, or those are going to be very important. So let's kind of just give a little quick definition, and then down below we'll get a better meaning, getting something more visual. Union, think of that as everything. Okay? Intersection, think of that as things that are common. Okay. Union, take it all, you have two different sets, put them together without any repeats. So if you got a 2 in one set and a 2 in another set, just put the 2 down one time. I'll kind of show you that here shortly. Intersection, denoted by like the upside down U. Okay, intersection. Okay, maybe like maybe it's like an N without the tail, so intersection. I kind of got that from an online guy I listen to sometimes, but it's denoted by it's the things that are common. So if you have a 2 in both sets, the intersection would be the 2. Okay, so the word or is used to indicate union. The word and is used to indicate intersection. So we kind of get that. Now let's kind of scroll down here and look, and let's get a better understanding visually. Okay, we have a set A. Inside this set A, which is this circle right here, in roster form, okay, we have 1, 2, and 3. In B, we have, which is this circle here, we have 2, 3, and 4. Okay, notice both of these are in roster form. Okay, these are the elements. These are the set names. Okay, so let's look at something. Let's do intersection. Okay, intersection would be A and B, which could also be seen as A, little upside down glass. That's how I kind of think of putting a glass over something and catching it, and or a little brackets that kind of come down and say what is the same, where are these things meeting. Okay, however you want to think of it. What is the intersection of these? Well, the intersection right there is going to be this right there. That's your intersection. Where do the two circles meet? Where do they overlap? Okay, so A intersect B would be 2 and 3. Well, how about union? Which would be A or B. Okay, which would also be A union B. Remember, that's everything. So now for that, is this blue pen going to work for me? We're going to take all that right there, and all this here. I notice it's kind of disappearing on me. We're going to take all this here, and all of this here, and all of that is going to be our union. So when you have the union of something, you would list everything with no repeats. Notice I'm going to put 1, 2, 3, 4. Okay, this is a set here, this is a set here. You can also look at it. Intersection is here, but the union is everything. But we don't have to list 2 and 3 twice. We just list it one time. Okay, so I'll make sure to put this on here. Note. You do not need to repeat elements in an union. Okay. Let's go down. Let's see an example. All right, example 1. Let's see here. Find the union and the intersection of the two sets. Okay, well, union. We've got a set here. We've got a set here. Union is everything without repeats. So if we have a union, we have a P union Q equals, put it in roster form, what would that be? Just make sure you put everything in here. So I'm going to have -6, -4, -3.5, -2, -1/2, 0, 2, 4, 6. And that would be the union. That is everything included. Well, how about P intersect Q? That's just what's the same. We can look through here. I'm going to do this pretty quick. Just whenever you're doing your homework, make sure to just be intentional. You've got -6, -6. I've got a 0 and a 0. I've got a 2 and a 2. So where do they intersect? Where would those circles cross? Okay. They cross, or where they overlap, 0, 2. Okay. These are elements common to both. Okay. Let's keep going. Okay. Finite, remember, that just means countable. Okay. You can count it. You go shopping, you're not going to have an infinite amount of apples. You're going to go in there, you buy a package of apples, you go up to the front, you put down the weight, it's going to say how many apples you got. I got 5. There you go. That's countable. Well, infinite, can't count it. So, cannot count. That'd be like me saying I have a set called stars. How many stars? Well, I can't count that because there's always going to be, I'm always going to find another star. Or a set called, real numbers. How many real numbers are they're infinite? Because they're going to keep going. Think of the largest number you can think of, add 1 to it. Okay, infinite is denoted by negative infinity or positive infinity, and you can graph it as negative infinity, positive infinity. Okay, set builder notation is just this. It's just another way to kind of write sets. Okay, this says x. This little bar right there means such that. So you would really read this x such that x is a positive integer less than 10. Okay, that's literally saying whenever you solve for x, x is going to be any positive integer less than 10. Okay, you'll see some of that on your homework. I think a couple of questions. Now, let's go over a few little examples here and kind of maybe just a little bit of a review over our greater than and less thans. Okay, whenever you were solving, if you remember doing this in 6th and 7th grade and even just recently, you're going to have a algebraic solving. Okay, we're going to have to graph. And then we're going to have to remember this word. You're going to see it a lot. Interval notation. Remember that. Okay. We're just going to do a few here. I'm going to just go and write them down. Okay. Let's start with these first, and I'm going to do 2 more at the bottom. So you see this here. X is less than, okay, you see that the little alligator mouth is going toward the 5. So X is less than 5. So notice it does not include 5 though. So when you see this right here, this is going to be an open parenthesis. I'll show you what I mean. You'll see it whenever we graph it here. Going to graph it, going to have a 0, we're going to have a 5. Okay, we know that x is less than 5, so x has to be everything in this direction, and it's heading toward the negative infinity. Okay, but it does not include 5. Since it does not include 5, we're going to have an open parenthesis, and it's going to look like that. So whenever we do the interval notation, we'll show that this thing goes to negative infinity, comma, starts at 5, but since it does not include 5, we're going to keep that open parenthesis. Well, let's go the opposite direction now. What if x is greater than 5? It's the same thing in reverse, okay? It's still going to be open. Okay, when we graph it, we'll graph the same way. Find 5 on your number line. But now, since x is greater than 5, it's going to go in this direction. It's going to go in the positive direction, but it's still going to be an open parenthesis starting at 5, but it's not going to include 5. So being that that's the case, you just take it, write down your 5, keep that open parenthesis, have it going in the positive direction. And just as a note, notice that no matter what, this right here, if you have an infinity right here, you're always going to have that bracket on one side. Whenever we get into Hawks, you'll see more what I mean whenever we start graphing on Hawks. Here, we've got x is less than or equal to 5. Well, same thing as before whenever we had the less than. Have your 0, have your 5. It's going to go in the negative direction, okay? But this means closed bracket, which means we're going to create like a little half box, okay? So whenever we graph this or put this in interval notation, we still have it going off toward negative infinity, and then we're going to have a 5. But instead of having another little half circle here or open parenthesis, we're going to have it say that. That's going to include 5. That means x can be all the numbers from 5 all the way back, including 5. Well, same thing in reverse. Except now we're going to have a closed. Okay, well, since we know it's closed, and it's going to be greater than, it's going to be that direction, let's close it off with a bracket. So whenever I decide to, write this in interval notation, I'll just start it off with the bracket. That basically says it's including the 5 and positive infinity. Now let's do a couple little weird ones that maybe just a little bit weird, but let's do negative 2 x 5 and then negative 2 x and 5. These right here always start reading in the middle. Okay, so x is greater than or equal to negative 2, or x is less than or equal to 5. Okay, these are going to be intersections. Okay, if we know we have 0 here, we can go ahead and plot the negative 2 and plot the 5. These are not to scale, obviously. Notice I have brackets. These are going to be closed. So I can put a bracket, and it says x is greater than negative 2. Well, negative 2 greater than is going to go this direction. But x is less than or equal to 5. So that's going to go this direction. Well, there's a bracket here, so we can put a bracket in between them. And this is saying that x is anything in between there, even including negative 2 and 5. So whenever we write this down in interval notation, we just write brackets negative 2 and 5. And last one. We see that there's not a less than or equal to under there, so we can put open, graph it the same way, and I do mean that. You can literally graph it the exact same way, except for now remember when you have open, because we can't include, your answer to x is now it cannot include negative 2, it cannot include 5, but it's everything in between those because x is greater than negative 2 and x is less than 5. So having said that, put a bracket here, put an open parenthesis there, close your parenthesis there. It's everything in between. So whenever we do the interval notation, you're going to get negative 2 and 5. And there is lesson 9.8. Okay? If you have any help, feel free to reach out. Don't forget, do the Hawks and make sure to do the practice. Good luck, guys.